Hello and welcome to another cRod education video about import offsets in c4d. Let me send ahead this only applies for patients with gated treatments which had a sentinel session. You might ask yourself what kind of a problem we have if we handle gated treatment plans in c4d. Think of the positioning part in Catalyst for a deep inspiration breath hold plan. As the imported plan is in deeper inspiration breath hold, so is the C position reference then. Meaning that we would need to do the patient setup in deep inspiration. So as this is not very handy for the patient, of course, cRod handles this in a rather elegant way. Long story short, we do a little trick and use the surface which we acquired during the sentinel session and transform it into a C position reference surface for patient setup. We can do this transformation automatically, but only if either the reference point in your planning system or the DICOM origin from the CT study matches with our Sentinel isocenter, which you can see here in the left picture. In this video, you will learn all the aspects of this topic and how you can handle these additional offsets that might occur. Before we go into details about offset import, let me start with some explanations and definitions to avoid misunderstandings. In this video, I will speak about several points in the DICOM environment, which are the CT and the Sentinel isocenter, the DICOM origin, the TPS user origin, or also called reference point, and of course the treatment isocenter. And here our CT and Sentinel systems already roll in to get ready. The CT isocenter is obviously the rotationally point of the CT or the cross-section of the red lasers inside of the CT gantry. Our second point, the isocenter of the Sentinel laser scanner, should match with the CT isocenter and can therefore be seen as the same point. You also check and compensate that match every morning during the Sentinel QA session. Third, the DICOM origin is an origin which defines a geometrical 0 point of the CT data. So it's the origin of the coordinate system of the CT data basically, and is set by the CT during the CT session when you zero the couch. Note here that the DICOM coordinate system for image modalities has a different coordinate system as cRod currently uses, as it has a flipped vertical axis. Each vendor for CTs handles the definition of their DICOM origin a bit different, so they position the origin not all at the same location. In general, try to acquire a Sentinel surface only in the zero couch position. This avoids additional laser offsets later on. So far so good. Now let's just have a little sub-chapter insert before we continue with our remaining points to show you how each CT vendor defines their DICOM origin, as this is important to understand that offset topic. Let's just jump directly into the definitions, starting with Canon and G. Canon Medical, formerly Toshiba Medical, and GE Healthcare CTs use the easiest position to set the DICOM origin. By pressing the 0 button on the gantry, all three axes will be zeroed, and the location of the origin matches with the CT isocenter, respectively the Sentinel isocenter. Next one is Siemens. Siemens CTs handles the couch 0 function almost similar, with only one exception. The vertical value in the DICOM origin cannot be zeroed. Only the lateral and the longitudinal values are reset once you press that button. The vertical value for the DICOM origin is defined by the couch height. You can see this value either on the gantry's display or in the Singo monitors in the tab Scan. Last but not least, to Philips CTs. The handling is similar to Siemens. You can do a reset of lateral and longitudinal axis, but again not the vertical. For the vertical value of the DICOM origin, Philips goes from the center of the bore, so that's basically the isocenter of the CT, down by the distance from the couch to the ISO, and then up again by 255 millimeters. So in the end, the dicom origin is mostly somewhere above the CT isocenter or close to it. How to apply these offsets to C4D will be explained later in this video. Good, let's continue with our remaining points, which are the TPS user origin or reference point. Sometimes it's also called point of interest. This is a new origin for the coordinate system in the TPS set by the user in the treatment planning system. The origin is typically set to the cross-section of your Beakley spots, which are applied to the patient's skin. This is then the offset you need to apply on your patient to get from the Beakley spots to the treatment isocenter. And last but not least, the treatment isocenter itself, of course. In the dicom environment, the treatment isocenter has coordinates in relation to the TPS user origin, which you can set, but also to the dicom origin. And guess what? C4D can import both of these offsets automatically. But should the TPS user origin or the dicom origin not match with the sentinel isocenter, so there is an additional offset, then you need to add this information into C4D, because otherwise we won't have a correct transformation of our surfaces. This can be added either when closing the sentinel session or when importing the treatment plan to C4D as a laser offset. Good, so far to our definitions. Now we can start. Now quickly to some other prerequisites just for our understanding. We will see different surfaces in C4D, the sentinel surface and the TPS surface. The sentinel surface is the surface which you acquire during the sentinel gating session, of course. You need this to choose the position of your primary and secondary gating point. The TPS surface is an external contour you import from your treatment plan to Catalyst. Usually you use this for patient positioning, but as the setup mode in Catalyst is meant to be done in free breathing, we can use the sentinel surface instead. However, both surfaces can be selected for C position, but the sentinel surface will be selected by default. Also note that the TPS surface is for a deep inspiration breath hold case, not in free breathing. The C4D software can handle different offsets automatically, depending on which option you have selected. To change that setting, log into C4D with administrator level. Go to Tools, Options, and look for the tab Import. On the bottom you will find Import Offset, where you can choose between CT reference point and CT origin, whereas CT reference point imports the isocenter offset from the TPS user origin, or in other words, your planned isocenter coordinates, and CT origin is the isocenter offset in relation to the dicom origin. The effect for both options is that the sentinel surface will be shifted by the offsets you import. So here we are doing our magic transformation basically. This is very important for gating, so that the gating spot is transferred correctly by the offsets, or in other words, remains on the same position where you had it during the CT procedure, but in relation to the newly imported isocenter from the treatment plan. Now to the actual import offsets. Let's start with the CT reference point option, which is also the default option. Our patient already had a sentinel session before, which you can find here. When we now import a treatment plan to C4D, we can first see that the sentinel session has already been chosen by the system automatically, based on the match of the ID of the patient. If you have more than one sentinel session, C4D will always automatically select the last one, but you can also choose from the drop-down list. And here we have our imported offset from the TPS user origin. Choose a template for your treatment case. For DIBH, I suggest breath hold gating, and click Import to apply all settings to this plan. You might get a notification that some of the patient's data, like the name or the birth date, differs from the existing one. The reason can be that not all that information was available or has been entered at the Sentinel session. Double check it and click Yes to update the patient data. Now let's have a look at our new C-position surface. As you can see, c4d created a copy of the Sentinel surface and shifted the IC center accordingly. Also, next to the surface from TPS, the body, we now have another reference which is for gating. It's the so-called cRespiration reference. As mentioned before, all gating settings are saved in this cRespiration reference. The gating spot has been correctly transferred by the imported offset to be in the same position as during the Sentinel session. Note that the offset option for CT reference point only works correctly if the TPS user origin or reference point matches with the Sentinel isocenter, or basically the center of the CT bore. By putting the user origin onto the cross-section of your Bickley spots in a DIBH scan, there will be still a remaining offset to the Sentinel surface, which comes from the deep inspiration of the patient. And now to the second option for import offset. By choosing the option CT origin, c4d will use the IC center coordinates in relation to the DICOM origin of the CT data. And as every CT vendor defines its DICOM origin differently, we first need to make sure that the DICOM origin matches with the Sentinel isocenter. Otherwise, we do have an additional unwanted offset. In general, I can give you the following advice. Wherever and whenever in your CT workflow you acquire the Sentinel surface, just make sure that you acquire it right after you pressed the zero couch button, or when the couch is in the zero position, longitudinally seen. This reduces potential mistakes with other offsets. And I already mentioned the ways of how CT vendors handles their DICOM origin, but here a short repetition. So again, for GE and Canon CTs, no further option is needed if you select the CT origin option as import offsets and you acquired the Sentinel surface in the zero couch position. For Siemens CTs, you need to compensate the DICOM origin by the vertical couch value. You can do that by either adding the couch value displayed on your CT as a laser offset straight after the Sentinel session, or when you import the treatment plan to c4d. The effect is the same. Just make sure to use the correct axis direction. Usually it is flipped, meaning that for a couch value of 243.5 displayed on your CT, you need to enter negative 243.5 for vertical. For Philips CTs, you need to take the vertical couch value. Let's say it's 243.5 millimeter again. Then you subtract 255 from that, which equals negative 11.5. And then use this value with another negative sign, making it positive 11.5. This is then the value you can enter into c4d as laser offset. Again, either after the Sentinel session or directly when you import the treatment plan. As this procedure is rather complex, it might be more convenient to use the CT reference point option for Philips CT users instead. But note the additional offset between free-breathing Sentinel surface and deep inspirated TPS surface mentioned before. This can be avoided by updating the C-position reference after the first fraction of catalyst. You can see how to do this in another CRAD education video. So let's follow through the import again. Before we do the import, we can check if a laser offset has already been applied to the Sentinel session by selecting the Sentinel session and switching to the settings in the main window. In the bottom left, the vSim laser offset tells us the entered value, which will appear during the import of the treatment plan. Now select Import and choose the treatment plan. Again, the Sentinel session to be connected to the plan is pre-selected automatically. And here we see our offset values, which are identical with our isocenter values, but with different coordinate system. Therefore, some axes are flipped or have different orientations. Next to the offset, we have the VSIM laser offset again. You don't need to do anything here, however, you could edit the value once again if necessary. Select the correct template for C position and C motion settings and choose Import. You might again get the information that the patient data differs. And when we check the surfaces, we see that our isocenter for C position is in a reasonable position for left breast treatment. Also, the cRespiration reference was generated and has the correct settings ready for gated treatment. Finally, I want to show you how to use and add a laser offset in the end of a sentinel session. Should your reference point, the cross-section of your Beakley markers, be in a different position than the sentinel isocenter, you can add this information in the end of a sentinel session. When you end the session, you will be asked if you want to add a laser offset. Choose Yes to add the information to the session. Note that the axis of the coordinate system of an external laser system might have a different orientation. c-RAD currently only supports the IEC 61217-2011 standard. Finally, also note for Siemens and Philips users. If you forgot to enter the vertical value and compensate after the sentinel session, the couch height value will be stored in the CT data and can be usually retrieved from the image properties of the CT data. That was it so far for the c4d import offsets. Thanks for watching this video, we hope it was helpful for you. If you have any further questions, please contact your c-RAD application specialist directly or visit us on crad.com.